Fourth grade. So Keto wants to say hi. Hi, Keto. Say hi to all the fourth graders. Keto. Hey, where'd you go? Hey, look. Say hi, fourth grade. Ooh. All right, this story is perfect for Keto because she really likes to look up things close. She wants to get on the chair, which she's not allowed right now, so she can see things closer. Remember, our essential question this week is, what can you discover when you look at something when you closely look at something? So we're going to read about a tool that allows us to see everyday objects up close. This genre is an expository. We're going to use this story, so it's a true story. We're going to use this story today and tomorrow to help us understand the concepts better. So look at the caption. Expository text most likely will have captions and photographs. So the caption, remember, I always stop at that word in yellow, so you need to make sure you follow along and read that out loud. Compare these grains of sugar with the magnified sugar crystal. So here is the sugar, and look at it up close in this picture. Isn't that beautiful? Did you know you were eating something that looks like rainbow colors? It's monochrome. So many chromatic. It's crazy that's what we're eating if we look it up close. Wow. All right, I'm going to continue to stop with those words in yellow so that you are reading them out loud with me. Does the picture on the left show a diamond or a glass prism? Look closer. Take a step back. You are too close. It is a picture of a sugar crystal. This extreme close-up was taken by an electron microscope, a tool that can an item to thousands of times its actual size. Pictures taken with a high-tech electron microscope are called photomicrographs. The sugar crystal on the left may look huge, but the word micro means small. We are seeing a small part of the sugar crystal up close. Photomicrography dates back to 1840 when a scientist named Alfred Donne first photographed images through a microscope. Around 1852, a German pharmacist made the first version of a camera that took photomicrographs. In 1882, Wilson Snowflake Bentley of Vermont became the first person to use a camera with a built-in to take pictures of snowflakes. His photographs show that there is no such thing as a snowflake. Each is unique. Nowadays, we have electron micrographs. So here are some photos. The caption says, the photographs of that Snowflake Bentley showed that snowflakes are shaped like hexagons. Look how many sides. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. They all have those 6 sides and 6 corners. The light microscopes you use in school are weak and do not show much detail. An electron microscope is a much more powerful tool, and it allows scientists to see things that we can't see with our own eyes, such as skin cells or dust mites. So even like the little dust in our house. Gross. The picture below is a close-up of human skin and shows the detail an electron microscope can capture. The more an image is magnified, the more detail you'll see in the photograph. The most magnification that a photomicrograph can capture is about 2 million times the original size. Magnified images have helped scientists to see what causes diseases. Over the years, scientists have learned how these diseases behave. Looking through microscopes, we have even learned what is inside a cell or how a snowflake into a drop of water. So here is the caption. This is a human fingerprint magnified by an electron microscope. So you can see it magnified 1 million times. And then here's our skin fingerprint at 2 million times zoomed in. Scientists use electron micrographs to see how objects change over time. For example, we can look at a piece of fruit to see how it decays. First, the fruit looks fresh. After a few days, it begins to soften. Then specks of mold appear and to it. Days pass and eventually the fruit is covered in mold. We can see these changes under the microscope far earlier than we can see them with just our eyes. Suppose you, on a day with friends. What would the sweat on your skin look like magnified? The possibilities are endless if you examine your world up close. Let's look at this caption. When the mold on a strawberry is looked at under an electron microscope, it resembles grapes. So here's the fresh strawberry, delicious. Here's the moldy strawberry, and then zoomed in. Look at these, they do look like grapes. So let's think of that essential question. How do electron microscopes help scientists? How do electron microscopes help scientists? Think about that question as we continue this week.